Hello. Hi. My name is Nandima Ture, and I'm an instructor at Community College of Philadelphia. Today we're going to be talking about logarithmic function. Hopefully you've all covered exponential function, ways of solving it, and the application of it. Today we're going to be talking about the inverse of exponential function, which is called logarithmic function. It's always important in mathematics to understand the application or the necessity of what you're doing, why you're doing it, why you're going to use it. Here's an example. It states, Brandon bought a government savings bond for $1,100. He was told that when the bond can be cashed in 5 years, he would get $1,444.48. If the interest on the bond is compounded annually, what is the interest rate on the bond? You say to yourself, how do I solve this? Where do I get start from? Well, let's look at the chart. You have a certain amount of money, which is $1,100, that you're going to put into a bank, in a savings bond. After 5 years, that money that you're going to get out of that bank is going to be $1,444.48. It's asking you, what is the interest rate? How do I solve that, you ask yourself. You use logarithmic function, and which we'll be explaining later on in the section. So here's where you started, which is the $1,100, and here's where you ended after 5 years, which is $1,444.48. Put a dot in the middle. Okay? So you start at 0. After 5 years, here's what you're getting. So the question is asked, what is the rate? How are you going? Are you increasing? What is the rate annually? Logarithmic function, or logarithm, is used in calculating this, which we'll explain at the end of this series of these videos. So first, let's start with introducing logarithmic function. Let's define it. What does it mean? What is the definition of a logarithmic function? What is logarithm, you ask? If you look in your math book, it says logarithm is defined as the quantity representing the power to which a fixed number, the base, must be raised to produce a given number, the argument. Huh? Can you say that again? You might be asking yourself, okay, think about 6 to the x. You have a number, 6. You're raising it to a power, means you're multiplying it by itself numerous times to get another number, 36, which we call the argument. So you want to know, what is this x? 6 raised to what power gives me 36? Well, we all know that 6 multiplied by 6 gives us a product of 36. How many times you multiply 6 by itself? You multiply it by itself twice. So thus forth, we write 6 squared equal to 36. Well, that 2 is what we're trying to figure out when we're doing logarithmic function, or logarithm. So how are we going to do that? As you, later on throughout the series, you figure out, we'll see how we do it. So let's find out, what are the professions that use logarithm? Why do I need to know it? How is it beneficial to me? If you want to calculate the speed of electrical signals, you are going to use logarithm. Who uses that mostly? Computer scientists and engineers. They use logarithm to calculate the speed of electrical signals from one modem to another. How does that work? You have computers. How does that work? You have your cell phone. How does the speed of electrical signals work? Logarithm is using that. What if you just moved to a new house? You got a new job. You want to find a house. You want to know the population growth. Well, you use logarithm to find out how does a population grow or how does it decline over time in a community. So if you're a business major, you want to go build a store, you want to know, will it be worth it for me to build my store in this neighborhood? Well, it's good to find out the population growth. What if you are a biology major or a chemistry major? Guess what? You use logarithmic function to study the nuclear and chain reaction. You like to study the brain? The brain has several neurons. How does the neuron travel fast in the brain? You use logarithmic function in that. Electrical signals in the brain is used in logarithmic function, the speed of it. How about if you're an investor, you want to put your money somewhere, you want to reach a certain interest on a loan. You use logarithmic function because you want to find out how is that loan, that money that I put in, after 25 years, how much am I going to get? Well, as you recognize, it's increasing. What is the annual increase? You use logarithmic function to calculate that. What if you say to yourself, all those occupations she said, is not mine. Why do I still need to know logarithmic function? If you have student loan, if you have car loan, if you have mortgage loan, you use logarithm because you want to calculate the rate or the time. That's actually used a lot of time in bank loans. You all know, some of you know the formula. It says amount is equal to principal multiplied by E, which is a mathematical constant, raised to the rate multiplied by time. If you want to calculate the rate or the time, you are going to use logarithmic function. So now let's look at the formula. What is the formula for logarithm? It states, suppose a is greater than 0 and a does not equal to 1. There is a number x such that log base a of y is equal to x if and only if a to the x equal to y. Let's go back to that 6 times 6 that we did. We have 6 multiplied by 6. We got 36. In exponential form, you say 6 squared is equal to 36. In logarithmic form, you will write log base. What is the base? Well, the base is 6. What are you trying to get? 6 raised to what power gives me 36? So you say log base 6 of 36 is equal to 2. As you see over here, here's my a, and my a is over here. So in this case, my a is 6, my a is 6. My y is 36, and my x is 2. So things to note is that logarithmic function is considered as the inverse of exponential function. You should also recognize that an exponential equation is an equivalent logarithmic form. You can always write it in an equivalent logarithmic form. And understand that logarithmic function tells you what the exponent is. Let's view another example. 3 times 3 times 3 times 3. How do we multiply this? Well, if you remember back in arithmetic, you will take 3 multiplied by 3, you get 9. You can take this 9 and multiply by 3, but I like to always do it the easy way. I'll take this 3 multiplied by this 3, and I get 9. Then I take this 9 multiplied by this 9, and I get what? 81. So 3 times 3 times 3 times 3 equal to 81. We can write this in two forms, in logarithmic form or in exponential form. So let's start off with the exponential form. We say 3 is the base, is raised to how many power? Means how many times you multiplying 3 by itself. I recognize I have 1, 2, 3, 4. So I'm multiplying 3 by itself 4 times to get an answer of 81. That is the exponential form. What about the logarithmic form? I have log base. Well, as you recognize, the base is 3. So log base 3 of 81 is equal to 4. So when you look at it, you recognize you're using the same numbers in the exponential form as you are in the logarithmic form. I see the 3 here that I see here. I see the 4, which I also see here, and I see the 81, which I also see here. These numbers have specific names for them. You have what we call the exponents, the base, and the arguments. So 3 is considered as the base. So that's why we say 3 raised to the 4th power equal to 81. And here we say log base 3 of 81 is equal to 4. The exponents is the power. Well, the exponent here is 4, and the exponent here is also 4. As you recognize what we said before, logarithm, you're trying to solve for the exponents. And lastly is the arguments. In exponential form, you want to find the arguments, which is this right here. In logarithmic form, majority of the time you will be given the arguments, and you want to find the exponents. I hope this helps you out, and we will continue in our next video in converting exponential form into logarithmic form. I hope this helps you out, and you can always look at your notes on your textbook to find out more help if you need it. Thank you very much.